As the title indicates, that we're going to talk about a bumpy road from traditional fossil fuel resources to biomass. The project that we're going to be uh, talking about is a ongoing effort, and we'll take you from day one that dates back roughly to the days, the start of my experience here at Penn State about 4 years ago, forward to today, and we're still moving. We've still got a ways to go moving the ball forward. Um, but when I got involved here, one of the having a lot of experience in Westmoreland County through my 22-year history working for West Penn Power Company, the local electric utility, uh, was to be aware of the existence of a former waste to energy plant located in Westmoreland County that had been shut down about 10 years ago, 10 to 15 years ago, and an interest that there would be a potential anchor plant if you could make the case for reviving that, repowering that, and bringing it back online. So we started off looking at this former waste energy plant, which led us to the plant we're going to talk about. But as the bullet points here say, the establishment of the Southwest PA Renewable Energy Incubator Project was one of the first efforts that I got underway, which was a more of an organic approach to determining the resources available, the level of interest, and beginning to uh, create the thought that these things were possible to move to biomass, and how would we go about doing that. So establishing an anchor facility was the original intent, and the intention was that after or while that anchor facility was established, we would have the opportunity to uh, grow the necessary ingredients to make biomass feasible. So um, that's how we got our roots here with the Southwestern PA Renewable Energy Incubator. Um, the process had support from our local county commissioners. We I put together a dossier, a pitch for R.K. Mellon Foundation funding, and was successful. Of course, the College of Agriculture, which we're all part of, was supportive of this approach. And the three businesses that became involved include Power Consultants, Inc., Tri-State Biofuels, a local pellet facility in our southwestern Pennsylvania county area, or southwestern Pennsylvania region area, and an organization called Ernst Conservation Seed, who has a large interest in uh, developing the implementation of large-scale switchgrass production. But the work or discussions on the original waste to energy plant led us to a neighboring facility, which is pictured here, and it is referred to as Greensburg Thermal LLC, which is a uh, plant that was built in order to provide steam for a variety of purposes to a state prison, which you can see to the left of this picture in the background. This state prison was originally served by the waste to energy plant that I mentioned, and which had been owned by the county commissioners here in Westmoreland County. And when the economics really finally took the project out of favor, the prison there, in a scramble, tried to find a third party that could step in in short order, build a plant, and provide them the steam necessary to operate the prison facility. Greensburg Thermal, which is a subsidiary of Power Consultants, Inc., which I mentioned in my support slide previous to this, stepped in on a turnkey basis to build, own, and operate this facility. And we'll talk in detail about just what is in the plant here and why this is was turned out to be the great opportunity that it is. The plant itself, as I said, is owned by this owned by Greensburg Thermal LLC, is a circulating fluidized bed combustion system rated at a little over 20 million BTUs per hour. So it's not a really large steam plant, but it's of considerable size. And the size, by the way, was predetermined by the steam load or the perceived steam load that the prison was being billed for by the former waste to energy plant, which turned out to be somewhat oversized, as it appears waste to energy plant had been overbilling the state prison in order to try and make the economics work. So a little bit of sidebar issue there. The plant went in a little bit larger than necessary, which supported then the next bullet point, the eventual inclusion of 2 steam turbines to generate electricity, which today is utilized totally behind the fence by the prison. The total installed capacity is 500 kW. The 2 turbines don't always operate together. It depends on the load at the plant. And the interesting design feature of the turbines is that they help the steam plant balance load. And by that I mean a prison load tends to vary quite a bit during the day, with a lot of steam requirement early in the day for hot water requirements and cooking and heating needs in the heating season, and then kind of tapers off during the day, but then ramps back up again in the evening as the cooking and hot water requirements ramp back up. And the facility operates utilizing the steam turbines to offset the load or to balance out the load of the system so that it kind of is able to run on a more even keel. The primary fuel that was designed for use in this plant is waste coal. In western Pennsylvania, a long history of coal mining. One of the resultant maybe negatives to that is an ample supply of waste coal, which in the old days used to pile up, and a lot of the remnants of that still exist. And in addition to that, we have an active coal industry today, which still continues to produce lower grade coal that falls into this waste coal category. Backup fuel for this facility, or to supply the heating needs of backup boilers, is fuel oil. So that the fuel oil component, of course, is off the charts right now as far as the operator is concerned. So it's very important that they have as high a reliability or availability capacity factor, so to speak, for the waste coal boiler, so that they're not utilizing that backup fuel oil. And this facility is staffed or manned 24/7. Although it is highly automated, there is a requirement that there be an on-site operator 24 hours a day. This is a screen chart or a view of the computer control system of the plant itself, and there's quite a bit of detail there. You can see on the upper right hand corner, the two the synchronous and induction turbines, the two turbines that I mentioned. Um, in this picture here, which dates back to 2009. At this point in time, the induction turbine on the right was operating at 144 kW. The synchronous turbine was not operating. Incidentally, the synchronous turbine in this system acts in place of or in lieu of a pressure reducing valve to reduce the steam pressure off the boiler to uh, the house needs of about 50 psi down from up over 100 psi. So they capture that excess pressure and convert it to electricity here, which really helps to improve the overall efficiency of the plant. Where without that steam reducing activity or mechanism there in the form of that synchronous generator would be merely a pressure reducing valve. So the induction generator also is operated as a condensing boiler or a condensing unit, where it captures excess or remaining steam, condenses the remaining steam coming back from the prison before it cycles back around through the bottom of the drawing there, through cooling towers and back to the inlet side of the boiler. So they tend to attempt to capture every stitch of heat out of this system before they return the condensing water back to be recycled. They have a fairly high efficiency here, high efficient rate of efficiency in the 60 to 65% range. The next picture here is taking a closer look at this circulating fluidized bed boiler, the features of which create the range of versatility that this system has. If you're not familiar with circulating fluidized bed systems, essentially the combustion bed in this system floats on a cushion of air, and its design is that it circulates the combustion fuel and creates a great deal of combustion air that is really what's responsible for its versatility in the type of fuels that it burns, as well as the complete combustion of that fuel that it attains. The system, there you can see the fans located on the left-hand side diagram there for combustion air that supports the bottom of the bed of the boiler, as well as the fan that in the middle of the screen there that helps to keep that fuel circulating or rolling over during the combustion process. So this system, because of its versatile nature and it's designed to handle a low-grade fuel, which is waste coal, lends itself to, like I said, a variety of fuels, not the least of which is the biomass option that we're going to talk about further. The business model is very interesting here. As I said, this is a third-party owned and operated facility. The deal is a 20-year contract in which the owner-operator of the plant has guaranteed to the state prison, a fixed price with certain escalators built in that helps to keep or protect the plant owner from any kind of short-term or risks associated with being involved in the energy industry. So the prison has the luxury of having long-term budgeting certainty as in terms of the heat and cooling and other process heat needs of the prison for this 20-year term. And it's a good thing, of course, for the plant operator because they get to build and amortize the cost of the facility over that 20-year term with certainty that their ends are going to be met. And it's turned out to be, in the state of Pennsylvania, one of the most efficient and cost-effective boiler plant operations in the portfolio. It was designed to use a high-end automation, as you saw from the screens on the previous two slides. And this combustion technology allows the use of this low grade and what ultimately turns out to be reasonably inexpensive and plentiful fuel. The workforce is under the auspices of the plant owner operator, so they hire, train, and retain their own workforce, and they're very flexible in they're jack of all trades in terms of keeping this plant operating as many hours of the day or of the year as possible. They have a very high system reliability, and the system as designed has met and continues to meet or exceed its emission requirements. One of the benefits of that circulating fluidized bed technology on a small scale. So with all these great things going for them, why was the plant owner interested in transitioning or introducing the concept of biomass? And in general, it was an option or an opportunity to improve overall system performance. While waste coal is plentiful, it's a very variable fuel source depending on the supplier that you're tapping into in any given truckload. Whether it was currently waste that was coming out of the current coal mining operation or a reclaimed POW somewhere across the southwestern Pennsylvania region, the age of the material, how long it had been laying above ground somewhere. So, mixing in biomass gives them a way of balancing out some of that variability. And that variability contributes to downtime because of the uncertainty of the content of that waste coal as it comes off a truck. There's downtime that has to do with clean out of the boiler from clinkering that occurs, other issues with wear and tear on the boiler because of this variable fuel nature, which leads us to this diversified fuel supply. The ability to go to more sources for a fuel supply. Bottom line also is that burning biomass reduces the amount of sulfur that goes into the fuel chamber, the combustion chamber on this facility. So right off the bat, air emissions have an improvement with the combination of biomass. The other thing is the incorporation of biomass lets them determine what in the current design of this plant works well with biomass in combination and what doesn't. And as they demonstrate the technology and the use of biomass, it'll help to tailor the next system or system changes to the current system to help them more suitably operate with biomass in the picture. And another component of this is while burning a biomass, a system like this that also generates electricity under the alternative energy portfolio legislation that was passed here in Pennsylvania about 6 years ago, 7 years ago actually. The system qualifies to market alternative energy credits, and that's going to come into play at the end of our discussion here today. So we'll just leave it at that and fill in the details on that point a little bit later. So what were the hurdles to introducing or making it an official plan to introduce biomass at this system? Well, first of all, while we live amongst plenty of biomass here in southwestern Pennsylvania in the form of our many forested acres, many acres of forest as well as many acres of agriculture. There is nobody in the nearby vicinity that's strictly in the business of supplying biomass for fuel purposes. So what we deal with is in helping to develop the supply chain of this is an educational hurdle to introduce potential suppliers to this new opportunity, but stress the importance that the biomass that would be part of the fuel supply needs to be competitive with the fuel we're trying to displace, which is a very low hurdle or a very low bar, that which is that waste coal number. We're going to talk about that in a little bit here. Fuel supply handling and storage is also an issue. Waste coal has very different properties in material handling than the typical biomass that you'll find, just in density and its pourability, so to speak, the tendency to bridge and its ability to be its density in the combustion chamber, because we're floating this fuel on a cushion of air. So we've got to be sensitive to all that. It's also its ability to absorb water is another issue. So storage of biomass is an issue. Believe it or not, DEP air permit modification, which is our Department of Environmental Protection, had been a very big challenge. We'll talk about that in a little more detail. And as I said, the fuel chain supply chain development here for fuel is one of the front burner issues where we still have a lot of work left to do. Basics of waste coal, as I said, it's a byproduct of the coal mining industry, past and present. Very variable BTU content. This is a pal that was sitting right outside in the yard at the plant. I took that picture earlier in the week. It's subject to moisture content variability issues. There's been an occasion when the truckloads have come into the plant during the winter in freezing conditions to dump, and the load was frozen solid in the bed of the truck, so they couldn't even dump the load out. So it's variability, it's soil, it's sulfur content. There's a lot of other junk in here, rock and shale, and even metal objects and things from history that are left in these piles that come in on these loads. But positives, of course, are it's quite abundant in our area, and it's actually beneficial to get rid of it, so it's fairly low cost. But it creates this last bullet point, which is a very low price to beat. And this is my number, $3 a million BTU. The plant operator will tell you, or they're sticking with about $2.38 a million BTU. But I believe we're not seeing we're not seeing the whole hand they're holding there when they throw that number out, the 238. I think $3 is a more reasonable number. But biomass options, in our area, of course, we have the forest component, wood chips or other forest products that we see on the right there, a big pile of wood chips, versus the ag-based biomass solution, which is under that blue tarp on the left, which is, in this case, is ground switchgrass. This is actually the back of the plant looking at the loading doors for the fuel bunkers. We'll get a little closer look at those. But typical price comparisons, I just ran through some numbers here. There's that low number for million BTUs at $3 for waste coal. Wood chips, which the last load that was purchased for the plant here was at $55 a ton, which at 10,000 or 10 million BTUs a ton is about $5.50 a million BTUs. Switchgrass, if you can get it for $85 a ton, ground would come in at about $7 a million BTUs. And wood pellets, just like we would use in home pellet stoves, home heat pellet stoves, at $200 a ton, which is a pretty very competitive price, would come in at about $15.38 a million dollars per dollars, double dollars there per BTU. Just for comparison, if we're trying to displace natural gas, we need to be at about $6 a million BTUs at $6 an MCF. Or if we're out there in replacing electricity for whatever reason, we would be at about $29.31 a million BTUs. So that kind of, the upper half of that kind of spells out the hurdle that we have to make wood chips on a dollar per, or biomass on a dollar per dollar basis competitive with that low value, low price waste coal. Now, another question that I have is the plant operator really operating on 100% waste coal, or is there regular bituminous grade coal mixed in with this? You know, that's kind of a close to the vest matter too. You know, we're not completely prying into each other's business here, but I'm skeptical about the fact that what we're dealing with here is totally waste coal. But on the fuel handling and storage matter, the left-hand picture here is a pile of wood chips that the plant operator got off a construction site where the land was cleared and the wood chips were randomly chipped. You can see we're sitting on a asphalt loading area here, and it's raining. So this fuel is fairly questionable grade as it when it dumped off the truck, but untarped and uncovered, you can see it's just a giant sponge for water. So your fuel handling is an issue because this fuel has to be protected from the elements. You can see on the right that same pile of switchgrass that the plant operator tarped when it came off the back of the triaxle. But still, this is a very cumbersome way for them to operate in having to shovel that load by load back into the fuel bunkers behind that pile. So addressing fuel handling and storage has been an issue that the plant operators been grappling with even this week. Let's go to the next slide here. The fuel bunkers in this plant, an empty one is pictured on the left there. You see at the top of this bunker is what's referred to as a grizzly, which is a grate that allows the waste coal typically to be broken up and fall in smaller pieces down to where it eventually finds the loading screw that moves the fuel into the day bins of this combustion system. But on the right is that ground switchgrass. You can see it has a tendency to bridge. You can see on the lower center of that picture where the material's hanging up in that grizzly, and so it doesn't flow the same way as the plant was designed to have material flow. when utilizing that waste coal option. So the plant operator has found that the best way to get that fuel evenly mixed into their system is to pre-mix it out on that loading area. So they're working out their operating requirements to get that fuel into the bunker in a kind of a 40-60 ratio of their waste coal to biomass fuel. This week, this is a picture at the plant. The plant owner has been having these fuel handling and storage bins built at the back of that loading area. And you can see they're using large concrete retaining wall type units to build 4 different storage bins, and that they use a backhoe typical to the one sitting in that right-hand picture to move their fuel around. These 4 bins will be dedicated, one to handling or storing waste coal, one for wood chips, a third to buy a product that they're developing at another location, which is a fuel pellet, which will be coal fines mixed with biomass. This product is under development, and then the bin you see there on the right is going to be for equipment storage facilities. These bins, when they're complete, will have hoop type enclosures over top of them to rainproof and waterproof the facility from the weather. So the progress continues slow but sure as we speak. Emissions permitting, another hurdle that I mentioned. It took 3 years for this plant, which has been operating for about 7 years, to get a permit approved to co-fire biomass. And of that, during that 3 years, they had to come back multiple times, on 3 separate occasions, to conduct full-scale air emissions testing, which involves bringing in an outside contractor to do air emissions testing. And as you can imagine, these were multiple day tests at considerable costs in dollars and time. So the bumpy road title to the talk today is, this is an indicator of the kinds of challenges that you have that you may not anticipate. You'd think that the DEP in the state of Pennsylvania would be very interested in actually introducing fuels that improve air emission quality. But as it turns out, this was new enough to the regulatory agency that they were feeling their way a good bit of the time, and needed a lot of confidence before they actually were able to make the leap and set these limits. So they've limited the SO2, sulfur dioxide, and nitrous oxide emissions. Of course, particulate emissions are an issue in our area, generally an area with a lot of coal-fired generation and the remnants of a once huge steel industry that still has coking operations in our region. So they were interested in and set specific limits on sulfur dioxide, nitrous oxide, particulate, odor emissions, and required that biomass fuel utilized in this facility exceed 5,000 BTUs per pound, which is about 10,000 or 10 million BTUs per ton, and requires that the facility be retested within 180 days of attaining full-scale operation, and thereafter every 5 years. I'm taking a look at Chuck's question here. By the way, that picture on the right when we talk about air emissions and particulate is a picture of the plant under full-scale operation. The stack itself is behind that cylindrical coal ash or fuel ash silo in the middle of the picture. If you can see particulate or other visible emissions from that stack, please raise your hand. The two covered stacks on the left-hand side of that picture, near where the steam vapor is emitting, are the stacks for the two backup fuel oil boilers, which aren't operating in this picture. Uh, the question that Chuck has there about air emissions, I believe because this involved biomass, Chuck, they were shooting from the hip, and if you're burning 1 ton of wood a year, I wouldn't say anything about it, Chuck. Just keep on doing what you're doing until someone bangs on your door. You're in good. You'll be okay. You can't operate, but don't set up next to a state prison like this guy is and expect the same the same treatment. Okay, talking about fuel chain or fuel supply chain development. We've spent a significant effort over the last year here identifying local resources, existing resources of both uh, woody biomass as well as agricultural biomass. Um, the uh, the goal or the challenge here, of course, is people that are involved in this may be producing wood chips for what's left of our pulping industry in the state. I've had reports that people on the eastern side or western side of Pittsburgh, about 50 miles from this plant location, are actually hauling wood chips to a paper plant in Conshohocken, Pennsylvania. Anybody know how far? Where's Conshohocken relative to the center of the state? That's got to be a long haul from the western side of Pittsburgh. But the thing is they have no familiarity with supplying a biomass um, system, so we're nor are we yet a reliable source of their or consumer of their material. So we've got a ways to go to get that confidence in the supply chain. I believe once the plant goes into full operation of utilizing biomass, that we'll get some um, uh, consistency in the purchase of this. Prices, we may be able to get a better price on the per ton basis and work out some better delivery deals. But there's still a lot of work left to do to get us there. Um, we've also worked with the local tree trimming industry to help to create another outlet for chips that are produced through that process. The grade on these wood chips is somewhat less than what one would find from sawmill type wood chips, but we're hoping to be able to make this uh, resource available for blending with the higher grade or more expensive wood chips from sawmill type operations in order to bring down the overall cost here. And the goal, of course, is that creating a blended fuel cost that's fairly close to being competitive with that $3 a million BTU coal price, and the intangible benefits that we see from improved reliability, from less downtime for boiler maintenance, that the overall biomass experience will become a natural. Well, it'll be make a lot of sense for the plant operator to operate in this uh, capacity and begin and keep grooming this local supply resource, so that not only can we utilize this local low-grade wood chips from the tree trimming industry, but also um, uh, hopefully develop more local resources for a higher grade wood chip from some of the uh, sawmill type operations in our area that now either consume all those wood chips for operations like wood drying, and but also who may be shipping out to uh, the pulp industry to the east of us. And then I wanted to just finish up here by talking a little bit about this energy credit issue. The energy credit is a result of this alternative energy portfolio legislation, which was passed back in Pennsylvania in 2004. And a system like this that's operating with at least some percentage of biomass has the uh, is permitted to market the or originate alternative energy credits, as were referred to in Pennsylvania, for each 1,000 kilowatt hours produced that's directly attributable to the biomass. And this is another way for the plant operator to pay down the cost of the higher price of that fuel. And I just did a little back of the envelope calculation here yesterday, assuming that the uh, energy efficiency of this plant, which is a combined heat and power plant, is at about 60%, and the delivered price of that ton of wood chips is at $55. I calculate that we need a value of about $21.87 for an alternative energy credit. That is equivalent to about 2 cents a kilowatt hour for that generation off of one of those two steam turbines located at the plant. Uh, Today we can get probably about $2.30 for that alternative energy credit. So we've got to improve this by about a factor of 10. And the way the market ramps up over the next 10 years, that's very doable, I believe. And we're in the process of registering this system for the plant owner so that they can get into this market and bring this other component into play for them. You know, the experience here has been that to make these plants operate, you cannot leave anything on the table. You need to take advantage of every option that you've got out there, and not the least of which is this added energy credit that needs to be factored in and play a part in the operation of the plant. So as you can see, the discussion here as it evolved from the concept of the Southwestern Pennsylvania Renewable Energy Incubator project, it's been a very organic process. It's involved the better part of 4 years to get it to the point we are today, where we're actually constructing storage facilities for the plant. I would say at this time next year, we could issue another report that would give you some total operating experience and report on how the market's actually developing. But it's been like a nurturing process to keep the interest there, to keep things alive. The state of the economy in Western Pennsylvania and the Mid-Atlantic region hasn't been any help in helping us get there either. You know, and of course, natural gas prices have also put a damper on the level of interest in biomass. So, you know, we've got a lot of things that could have been supporting that haven't been, but we've kept our shoulder to the wheel, and I believe we'll continue to make progress. I would say at that point, thanks, and Thanks for your attention, and entertain any questions that anyone has uh, to throw out there for us.
Okay, thanks very much, Ed. Very informative, and it's good to see these demonstration pilot examples that can be hopefully scaled up as the economies allow us to make it happen, and the demand is there, and we all know the supply is there. So um, please type in your questions. I see Dan has one. Can you read it? Yes.
Yeah, Dan. Yeah, the question is about support from the general public, and we have uh, worked with the local media to get some stories out in the Western Pennsylvania region from time to time to update people interested in the industry about this. But in general, we've kind of kept a low profile on this pending uh, the receipt of the air permit. We didn't want to raise any undue uh, overemphasis of the fact that we're burning biomass, and that it was going to be emitted into the local air until we had the air permit in pocket, which we do now. Uh, and I would say as we move forward here, I would we were hesitant to get more out into the public on this topic until now, but I believe we're okay with that now, and um, no support, but likewise no detractors. We're no, the question is about detraction from the coal industry. Um, no, there hasn't been any uh, issues with the coal industry. The interface between us and the coal industries is really the haulers. So the same people that are going to haul waste coal to this facility are those that will haul biomass. And, it's just another outlet, whether it's, uh, this isn't a plant of the scale large enough to get on the radar screen of any of the large coal players in our area, in my opinion. And supportive, the supportive component of that, yeah, I mean, this supports the cleanup of this waste coal uh, problem that we have in Western Pennsylvania. So, that is, the DEP is supportive of that. State and local government is supportive of the environmental benefits of improves the utilization of that waste coal resource. So I think when we have a good story to tell, that we will find support for that. I say a good story, but a more complete story.